Okay, this is University of California at Santa Cruz People's Physics Textbook, Chapter 3, One-Dimensional Motion, number 16, Part A. And the problem basically describes a helicopter moving upwards at 12 meters per second with a man dangling below a rope who lets go of the rope at 20 meters above the origin. So he becomes a projectile, obviously, when he lets go of the rope. His acceleration becomes negative 9.8 meters per second squared. There are four parts to the question. The first is, what's the person's final velocity when he reaches the origin? How long will it take for the person to reach the origin? How high above the ground does the person get at the apex of his flight? And after 3 seconds of free fall, how far apart are the helicopter and the man? So we're only going to do part A, and that is, what's the final velocity of the person after falling 20 meters? So this is one of the fancy kinematics equations. No average velocity, no time. And so we're going to isolate final velocity. So we start with final velocity squared minus initial velocity squared equals 2 multiplied by the acceleration multiplied by the displacement. We add initial velocity squared to both sides, undoing the subtraction, pushing this term over here. Then we have to undo squaring final velocity, and so we take the square root, or raise both sides to the 1/2 power. So this entire term is underneath this radical, that is raised to the 1/2 power. We're going to take the square root of this entire term. You simply plug in all the given information. So negative 9.8 is the acceleration. Our displacement is negative 20 meters because our final position is 0 and our initial is 20 meters above the ground. Our initial velocity is 12 meters per second. When you grind through the math, these two terms, the two negatives become positive. Add these two terms, and there's two solutions to this radical, that is plus or minus, but after falling 20 meters, the person is obviously going to be going down at negative 23 meters per second, or in America, negative 51 miles per hour. So that is part A, number 16, chapter 3, One-Dimensional Motion of University of California, Santa Cruz People's Physics Textbook.